till this point, all the videos have been quite obviously separate. You know, when I'm doing one ring, then another. But this is where the lines start to blur, because what I'm now doing is using these celestial longitudes to map out the positions of the tropics and poles. But I don't, you know, in theory, I don't know where the heights of these should be. Let's put that up there, maybe. Like I said, obviously the equator goes in the middle, but where to position this and this. So what I've done is look back at this and thought, well, I like the spacings I had on this, and this was made at quarter scale. So I've measured the distance between the top of that ring, and then there and that ring, and so it works out approximately 40 mil gap. Now this is a quarter scale, so that means 160 mil. So what I've just done is had a little trial run at positioning lines 160 mil. So here's, for example, the position of the equator ring, and then sorry, let me just find, okay, there's a couple in this reflective light, there's a couple lines which would denote the next band up, which would be a tropic, and then here's the next couple lines up which would denote the pole, and then reach the top. So what I did is I went round to test the theory that it should be 160 mil gap, and I've done that on all four sides at the minute, and I reckon that 160 mil is a smidge too much, and it should be more like 159, because what I did is I positioned a ruler on here on its side, not on the flat, on its side, so not like that, on its side, and I rocked it up until I got to 160 mil and 185, measured that, then I moved the ruler on to that point there, rocked it up till I got to 160 mil and 185, measured it, and then what this is these numbers here, 5, 2, 3, 3, relate to how much that was too much by. So like, for example, on here, I was measuring to this, like the seam line, so to speak. So this one says 5. So with here, 160 mil would have been about where my finger is. So it was about 5 mil too much. So, you know, 5, 2, 3, 5, 2, 3, and 3. I'm going to say on average, it's a mil too much. I mean, you're never going to detect by eye the, you know, whether one is like a millimeter closer to the top than the other, but I just want to get it as damn near perfect as possible. So what I'm going to do is now measure about 159 mil, and I'll record that process. That's bang on perfect. Like, that's bang on perfect for that. That's all. Stick my note, actually. Now we come to the hard part of making the beveled hoops that form the poles and the tropics. So this is one pole that I've done, and as I understand it, there's a typical system for calculating how much to bend a bar on its hard axis before then bending it on its easy axis to create the bevel. So to bend a beveled hoop, you need to pre-bend it on its hard axis and then bend it on its easy axis. You'd seen the previous video, or the beginning of this video, that I've pre-marked these bars with the targets spots of where the beveled hoops need to go. There we go. So if I put this on, what you'll see, I just need to shimmy it around a smidge, but anyway, it sits perfectly to the contour of this, and it sits perfectly like within its dots, top and bottom, top and bottom. Now, when I tried the sort of usual method of making a beveled hoop, or how to calculate how to make a beveled hoop, it didn't work. So and I tried it several times. Here, there goes my good hoop that I spent hours making. So you can quite clearly see, if I just sort of push this down, that the pitch of this angle that comes out was far too steep. I will go into how to do these beveled hoops using the traditional sort of calculations, because I think it's still going to work for the tropics, because that pitch is less, or is steeper. I think it will work for that. But for now, I'll just go into how I'm doing the poles, because I have to do another pole. And so what I have marked up on here is the top and bottom, top and bottom, top and bottom. So what I did was measured across. This is how I eventually got it to work. Whether it's going to work again in future for other spheres, I don't know. But what I did is I measured across from the bottom dots to the bottom dots. So that's the largest internal diameter, and that was 370 mil. I added on 25 mil, which was the width of the bar, and I rolled a complete hoop to match the internal diameter internally, 370. From that point, I then bent it on its hard axis, and that brought it into the correct curvature. So I'm going to video that process. I flipped the sphere upside down, so now we're working on what was the bottom, and as you can see, I've rolled the 25 by 6 mil bar on its edge into a complete hoop, and as I was trying to describe earlier, I've rolled it so that there's one mark and the other marks here, so it matches the internal diameter of this hoop matches the largest diameter of like what it would be at the bottom of the bevel. So again, this method is not the method that like the book say to do. It's just one that I've sort of found that works. Now, as you come into bending it on the easy axis, I'm not worried that it's, there's springing up. I'm not worried about that in a minute. As you come onto bending it on the easy axis, it's going to tighten up. So the fact that actually the top of the hoop is meant to be here and up here and up here, these ends are going to start to overlap, and basically what I'm going to do is cut the excess off as I go. until it's all sitting right. Now, the way the book says to do it is that you can pre-calculate how much material is needed, and you know, so hey presto, when you bend the two ends round, they come and they touch, and you've got no excess. This way isn't as like neat as that, I guess, because it does rely on you cutting bits off as you go, but at least it's getting me to the solution. So one of the key features of a fly press is the depth stop, so that you don't ever bump, well, so you can ensure you're always pulling it down to the same point. So this depth stop here, and you can spin it round and tighten it up. What I'm going to use in the top is just this bit of bar with a radiused edge, and then underneath these blocks. So if I just get this up in here, get that centered. So this hoop's 6mm diameter thick, so that's a piece of 6mm scrap. So what I can do is just position that there. So if I spin the depth stop down, where's my so if I was to lock that off, there, then the fly press wouldn't be able to go down any further than there, but I want it to be able to go a little bit further down, so I'm going to rotate that back to about there, then tighten that up. So now I know that I'm going to get a constant pressure every time I pull the fly press down. So now it's just bending it on the easy axis. The noise of something irritating me. So what might be clear from that is a bevel starts to appear. Quite clearly see it there. Now I've got one already done. Here, so you can see that I'm quite a way off in terms of pitch. So what I did the first time round is offered this one up and sort of checked to see how it was going. Well, I can see that this one's way off, so I'm going to increase this. Try about there. I'm just going to check it on the thing. So when I did the first one, I did actually have the foresight to mark on here, probably the best way. So there's like a seam line here. So what I did was I put a mark on here where that seam line ended up when I did the first one. So I'm going to bring it closer to this mark now, because I've still got a way to go. Obviously I've got a reference point here of where it probably is going to end up being. I'm going to stop a little shy of it because I don't want it, last thing I want to do is go too far, but I'll work up to it. First thing I'm actually going to do is trim off some of this excess. So is the excess taken off. Okay, so we're very close now, but I just need to take off these excesses again. One final little pass. So these ends are just I can just push that with my fingers for them to join up. So I'm going to take this over to the hoop and show the next bit. Ah. Okay, so it's falling within all its marks. So I'm going to do a couple dots of weld, top and bottom. So that's just getting small amounts of weld top and bottom. So I'm going to ultimately cover that. So the objective of the exercise there is just to cover that seam, so keeping it on here so the thing itself is like its own clamping jig. So if I unpop that, and then take these off, it should hold its shape. So if I rotate it round, it always stays within the marks. And what I'll do is I'll clamp it down, and I'll be welding from the underside, so it won't have visible weld. So I'll grind all these bits back, so ultimately it will just be like a seamless hoop and the welds will be hidden underneath. Before I was mentioning a method that, like a sort of tried and tested method for getting the bevel angle, or more to the point, the radius that you need to pre-bend these flat bars to on their hard axis. And I was saying that how it didn't sort of work for this one. It's worked much better for this one. I'm going to quickly talk through what the method is. So basically, this bar here on the floor is, I've already bent this to the right. This is for another one of those hoops. This is now bent to the right radius. So let's say, for the sake of argument, the internal diameter from the top to the top is 10, and the internal diameter from the bottom to the bottom is 12. What you do is count out 5, count out 5, and on the top count out 6, count out 6, and then you draw a line to like the vanishing point, so like through there till it meets this line. Same thing again here. Obviously I'm doing this freehand, whatever. And then you'd get a pair of compasses and you'd strike, first of all, an arc here, starting from, you know, like compasses set there and there, doing that, and then again the same thing here, here. Now that's horrible drawing, I know, but in theory this arc here is meant to be the same width as this, and those two lines up here, the space of them apart is the width of the bar we're using. So this is 25 mil, so for the sake of argument that's 25 mil apart there. So this the radiuses that you get would also be 25 mil, and that radius there is the radius that you pre-bend the bar to. I do have this up on my board over here, but my board's become so cluttered with other lines that, I mean, I can just about make it out. It's here. But with all the other lines on it, it's pretty hard to make it out, so I thought I'd just draw it on the floor. I've got to admit that I forgot to record the bending of this on the easy axis. It's been so damn cold in the workshop that last night I just wanted to get going, so I didn't even think to pick up my phone and record it. But in any case, it's not on the same process as this, bending that one on the easy axis. Though the only thing with this one is that I did bend it with the fly press, but then also this was my old ring roller from yonks ago. And that was superseded by that one. So you can see the size jump I made. Obviously, this is a manual one. You turn the handle at the top. There's a bit that goes in there. And then it winds manually with the handle on the back. So what I did actually is I once I'd pre-rolled it on that difficult axis, I sort of fed it in and incrementally sort of pushed it through. So it was going through like this, but that was really just to smooth out any little inconsistencies that developed from the fly press. But anyway, so I've paired them. So that's for the bottom side, and these ones are on the top. So now it's going to be a case of grinding back the weld that's on the top here, and then welding them against the underside.